Buenos dias todos, a todos. And as you can see, that's about the extent of my Spanish. Welcome, everybody. I'm incredibly privileged to be here among these real technical whizzes. I'm humbled. So I'm going to be telling you about some geospatial infrastructure work that we've been doing at the Harvard Center for Geographic Analysis. I manage a small team that develops platforms to support research across all schools at Harvard. Our mission at this center is to work sort of in-house consultants for everybody, all schools, business school, health, public health, everybody. So we take a very interdisciplinary approach. We use a lot of Python, and everything we do is open source, up on GitHub. Most of the systems we build, the platforms we build, we actually host and make available for anybody to use. So I'm going to talk more about these systems, but before that, since I'm the first speaker, and I think the rest of you are going to be talking really, much more technically than I am, I'm going to jump back in time for a moment. Any of you recognize this guy? Raise your hand. Let's see. Okay, so Eric Raymond wrote this book, Cathedral and the Bazaar. And I discovered Python when I wrote this. He advocated strongly for Python, and among many other things. I was actually, so 1999, working for a consulting firm that developed GIS systems for local and state government. I was working for Pennsylvania Department of Transportation. I spent most of my time, 90% of my time, for a good 6 months, I was dealing with integration, interoperability, licensing, for various proprietary systems. And that was when I stumbled across this book. And if you haven't read it, I would highly recommend reading it, even though you could say it's dated, but I think it's still very relevant. So reading this was a revelation for me. At that moment, I knew open source was going to be the way for me. And I just had to figure out how to bring it into my own career. So that was a long time ago. Where are we now? This is just Ben Lewis's very crude summary of what seems like an extremely successful last 20 years for open source. Partly, I think, credited to Eric Raymond, who not only wrote the book, but was instrumental in kicking off the open source software movement, sort of differentiating, making more friendly, free software as defined by Richard Stallman. So we've got open source on most of the world's web servers. We've got these amazing projects which have very broad developer communities. Python is probably the most often taught language in computer science courses. I don't know, people might correct me on that. And open source is core technology for the world's best capitalized and most powerful companies, which I think leads to some interesting situations, like the one we're in now, which I'll touch on briefly and not bore you, hopefully. And it's become essential in the all-pervasive digital ecosystem that we're all swimming in pretty much all the time now. Cute animal picture, because I'm going to lay something a little heavy on you. So there's a flip side to the tech boom. I just discovered this book. It was written by, coincidentally, a Harvard professor, but I don't know her. But somebody told me about it, and I read it, and it was like another Eric Raymond moment. I was thinking, oh my God, this is such a persuasive description of where we are. She talks about where we are now as a new form of capitalism has been invented, according to her and some others. She calls it a radically disembedded and extractive variant of information capitalism based on the commodification of reality and its transformation to behavioral data for analysis and sales. So I'm just going to leave it at that. If this resonates and you want to talk about this more with anybody or me, feel free. I'm really interested in figuring out what to do from here in this regard. But I'm also bringing it up because there's a moral dimension to coding, and there's a moral dimension to architectures, and we just need to keep those in mind. What that means, how that plays out, your careers, my career, I don't know yet. So back to the cozy world of open source, geospatial platform development within a prestigious university. So we serve a large group of people, all of whom need geospatial, they just don't all know it, luckily, at the same time. Lots of students, teachers, staff. We are now 4 people, so we've gone through some recent reworking and reorganization, and so we're kind of merged with this Institute for Quantitative Social Science. So because we're small and we've got a lot of people who we need to help, wherever possible, if we've got a lot of requests and we can kind of define those, refine those into a set of requirements that could be possibly served using more of a platform-based approach, we do so. And so we built several systems. They all really have one goal, which is really the mission of our group, which is to lower barriers to the access of geospatial technology for scholars. Quick overview of some of the platforms. Key one is World Map. We are in an extended process of rewriting the whole thing to catch up with the latest version of GeoNode, which it's based on. We're still running the old version, but we're probably a month away from the new. But in the meantime, we've got kind of continual groups of folks who want to build on World Map, and we've got 2 currently, one in China and one in Japan, who are using World Map for their own purposes. And then we've got a couple of related systems, HyperMap, which we built really to solve the problem with search. Once we put this platform up and made it open, we had 20, 30,000 layers really quickly. And that inspired us to think about a good search tool for geodata, which really didn't exist. I don't think it really still does exist. MapWarper, which is an online referencing platform that we borrowed from Tim Waters, and so that's not really ours, but we use it a lot. And then we've attempted to build a big data platform, really an experiment to see how far we could push Solr for searching and visualizing geospatially hundreds of millions or even billions of things. And then we're working with a GPU database company that actually incubated with us a couple years ago. They've open sourced their GPU database, and we're kind of exploring it, looking for good research use cases for it. So I'm going to talk to you briefly about World Map. This is the front page. You can create a map, few maps others have built, and read about the system. So World Map lets people basically bring lots of layers together, their own, others. Some of them are local to the system, some of them are remote. You can upload your own data, and then you can curate it, save it, share it. And there's a variety of ways of controlling access, somewhat fine-grained. So clearly you can discover other people's data. So it's really about mashups. There's not much analytical going on, though there could be. PostGIS, which is behind the scenes, has a lot of potential in that regard. We just haven't had somebody come forward to fund such an enhancement. And that's how World Map's been built. It's been built by people coming forward and saying, well, wow, it really does like 90% of what I need to do. Could it do this? And we'd say, yeah, you know, for a few $1,000s or, you know, some relatively small amount of money, we can add that. And then that gets added for everybody. And that's worked out really well. Creating maps so we can do data-driven maps, so the attributes drive the symbology, and collaboration. It's really all about collaboration. Letting scholars also publish maps associated with publications, and publishing maps for somebody who isn't a geo person isn't terribly easy. So World Map is based on GeoNode. GeoNode takes advantage of, really uses Django as its main wrapper technology. GeoServer is the server. Map server, occasionally we've plugged in. And then down here we've got Lucene, Solar, and PostGIS. And the good standard geospatial libraries, OGR, Proj4, at the bottom. So a lot of groups inside and outside Harvard have contributed to either World Map or GeoNode, and usually once they've contributed to one, they're really contributing to both. These current collaborators and some groups in Boston, a few others, and then World Bank wrote the initial version of GeoNode, and then so State Department is a significant user. NOAA, the UN World Food Program runs a number of GeoNode instances, Australian government, MapStory Foundation. So fairly big community. It's certainly the biggest Python-based geospatial CMS out there. And it's evolving quickly. So yeah, we chose GeoNode partly because we liked Django. Python we found is easy to learn for non-computer scientists, relatively so. Encourages interdisciplinary work, kind of a Swiss Army knife, as you all know. And it's strong for data science and machine learning, which we also do, but we don't do in the platform sense. So. We do have projects where we're getting into some of that stuff. And then strong integration with R is especially important because we work in this Institute for Quantitative Social Science. So this is the front page of the Zhejiang University instance that they've just set up. This is the beginnings of Japanese old maps online being developed out of Ritsumeikan University. And I'm just going to show you some of these curated collections that people have built over the years. The whole system started with Africa Map, and a professor who had tons of data on Africa wanted to get that stuff up on the web. And we did so pretty successfully way back in, this goes all the way back to 2008, when just being able to lay relatively large data sets down on Google's Great Base Maps was revolutionary in the academic world, and then being able to have lots of your own data sets there that you could turn on and off, explore, control symbology on, use to collaborate, was really exciting for people, and people would ask us to clone the system that we wrote from scratch. The original World Map was this. Standalone system, and we'd clone it, and we realized, you know what, we really need to take a more of a content management system approach. And many other maps since then have gotten built, some of them using, very large amounts of vector and raster data. This one is by Kelly O'Neill, history professor, she went and scanned a couple of atlases, Russian atlases, and then georeferenced them, and ended up sort of building a Google base maps for imperial Russia 200 years ago that now she's laying down all kinds of new data sets on top of and deriving new data sets from. We set up an instance right after the Japan earthquake. There was a lot of data out there and available from the Japanese government, but none of it was online. And so this system let us sort of rapidly get this stuff up and online and sort of shared. And that's a lot of what World Map gets used for. You know, it's just sometimes it's the easiest way to get data up and make it available to others. A couple folks in a nearby department have been working on mapping China. So they've put together some definitive data sets on transportation, demographics, and lots of other things. So, and all these data sets, they're here, you know, curated within this map called China Map, but they're all available. If you go in there and just start your own thing and start searching, you can find them and start pulling them in. And as I started preparing for this talk, I went in to see what there is for Colombia and Bogota, and there's a lot of stuff there. So hopefully at the end I'll have a chance, or soon I'll have a chance to demo the system a little bit. Another scholarly map on China. So that was World Map. HyperMap was a system that I was talking about that we developed really to help solve the search problem for starting with world map data, where we had a lot of layers. But we thought, well, when we applied for the grant, while we're at it, why don't we, you know, make it so that it could really flexibly and properly bring in remote layers as well. So service-based layers, not just stuff that we had on our server, but stuff that was coming off of other people's servers and being served up using something called WMS, or Web Mapping Services, and Esri has their own version of that called Esri REST. And we said, you know what, let's build a system that could harvest from those remote servers and bring them together and make them almost appear like first-class citizens in the system along with the local data. Well, the local data, of course, people can change symbology. The remote layers, they can't. Not yet anyway, though there are ways that could happen. So we got some funding and we built it. And yeah, this is our logic for that, sorry. Lots of layers. I made the case that, you know, we sort of take it for granted when we can find pretty much anything pretty quickly using the great search engines of Google and others. And DuckDuckGo, which I just started playing with and found it was surprisingly effective after I read Surveillance Capitalism. And with regard to search, for geospatial information is kind of where HTML was in 1995, right? There's really no good search engine for spatial data. And I don't think we've solved the problem with HyperMap. We could. It could be the beginning of a solution, but it's not there yet. So yeah, data is spread all over the place, geospatial data. A lot of it's not even on the web. It's on people's hard drives or buried in archives. And it's not done that way because people are trying to protect it or keep it, you know, from prying eyes. There's no privacy issue around it. It's just they had no place to put it. They had no place to put it online, make it available online. You know, it's a lot easier to take a text document and make it available online than it is a a map of all the buildings in Kyoto, in 1850. You need to have a little bit, you need to have some technical chops, or you need to have a developer or somebody to get that happening. And so, this is about bringing this stuff out of the woodwork, getting it into the light of the web so that researchers can use it. Got some funding. We argued that this could scale. We had ideas about how we were going to do that using solar, and something we developed within solar, working with a top Lucene solar developer named David Smiley, which is 2D faceting, which lets us produce heat maps of complex collections of spatial materials and return those results extremely fast, even with millions or billions of objects. And if you know anything about geospatial, you know that one thing it does not do, typically in traditional GIS systems, is scale. So if you've got 1 million features in QGIS, or 1 million features in a lot of web-based systems, well, which you just won't have on web-based systems because they won't let you put that much there. It's going to work like you'll be waiting minutes for responses to come back. So yeah, we built this, it's a spatial data infrastructure in the GIS lingo, but we then grafted modern search capabilities onto it, and that's HYPERMAP. We also developed temporal faceting, and we wrote a time miner to take a lot of the data that was flowing in, which didn't have nicely structured temporal signatures, and kind of harvest that and massage it such that the end UI supports searching by time as well as space. We also use something called map proxy. Map proxy is really cool because, well, as I mentioned, GIS doesn't scale well. These services don't scale well. So we decided to set up map proxy in front of everything, both our local layers and our remote layers, so that anytime a map is viewed, it's cached. And that means that no tile, you're familiar with tiles in Google Maps. We tile everything using the same paradigm. No tile ever has to be generated twice, right? So that saves massive amounts of compute power. Of course, when you change styles on something, you need to refresh the cache, but 99% of the time you don't. And it also speeds up remote service access and visualization, makes the user experience much better, reduces the load on the remote system. It also lets us do reprojections on the fly. So data comes in all sorts of projections, Mercator and Albers, and it's a zoo. Geospatial is a zoo of different projection spaces. As long as we can recognize the projection, we can put it all into a common space when we cache it. So the vision is a comprehensive registry. We crawled the web for spatial service and file signatures and harvested as many as we could. And we make the search engine available via a public API, so you don't have to come through World Map to look at it. And we also gather uptime and usage statistics on the stuff that flows through World Map, so that we can gradually improve the quality of search results. We know how much stuff is getting looked at, and we can gradually improve search over time. This is some super simple logic for a time miner. This was the original. It really did a very decent job. Now somebody's working on more of a machine learning approach. It'll be interesting to see how much better that gets. Quick overview of the architecture world map of HYPERMAP. So here we've got our registry. Oops, this is not working. Oh, it's working, but all right. So over at the right, solar elastic search. Oh, I'm untethered here, so search index. We harvest our remote services, push them into Postgres from where it goes into Solar. We use Celery and RabbitMQ for asynchronous task management. Django wraps the whole thing. Yeah, and there's a list of the various projects we use. So here's a quick CAN demo of how the system works. World map together with HyperMap. You go in, you create a map, and you're in a blank template. You can then add layers over here, and you get this UI where we produce a heat map of all the overlapping bounding boxes. Here we've got 36,000. And you can mouse over, you see the numbers of maps at any location. You can zoom in here as well. And you can search by keyword. You can search by where the data is coming from, like what server it's coming from. You can search by the type of service. And as you zoom on the map, you're searching by space. And using this time bar, you can also search by time. And then over on the right, we're always returning the results we think are the most relevant. And we're doing this. This is map proxy with the instant preview of anything. So it's already previewed, done a cache at this particular zoom extent, which lets us kind of provide a geospatially accurate thumbnail. And then as you find stuff you like, you can add them to the cart and load them to the map, and then you're kind of off to the races, and you can use some of the additional capabilities of World Map for sharing or curating, changing order, adding your own data, uploading your own materials to it, and so on. This is just another way in. We're coming in and we're looking at some data here in the Middle East. And as you see, the list refreshes over there as soon as you've zoomed, so that we've done a spatial query. Now we're doing a query by the owner of the data. So we see that this guy, Martin, has a whole lot of stuff on energy and oil. And now we're going to refine it by just saying, OK, only give us the stuff that mentions oil. And as you can see, some of the stuff most of the stuff over there doesn't have dates. Some of it does. And so we're, again, mousing over, looking for stuff. We're also returning an abstract of the data in the UI so that you can kind of get a sense of what the stuff is before you load it. So add a few of those. And yeah, and then we can zoom in. This one, I think, is a local layer. So yeah. And we can also click on features, return attributes, information about the features. That's the identify command there. Oil refineries, yeah. And then as you mouse over, you can see where the features are on the map. Yeah, so I think we're just gonna, we're gonna zoom in a little more here. And we've got some pipeline data. And we've also got raster data here that we can load. And then we can, once we got the stuff in the map, we can choose what displays on top of what. And then we could save our map. And then we would have this as a view that we could share with anybody. We've also got this tool up on the top called Link. Once you've saved the map, once you've given it a name, and you've given it a URL, sort of a full-fledged object on the web, you can also do fine-grained linkages to anything in the system and share those as URLs as well. And with that, I think I'm just going to move on here to a Bogota demo. So let's just see how this works, because I haven't demoed on this machine before. So first, I need to have the mouse. And then we're going to zoom in here. Go to Chrome. OK, so we're going to go to worldmap.harvard.edu. And I'm just going to give a quick tour of the system. So again, so this is not projecting any longer. Why is that? Dun, 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 dun. Because I have that. Somebody help me not have this display. Sorry. Yeah, so we can create a map. We can view maps that others have created. We're going to go in and we're just going to look at maps that people have built, which this is not everything on Colombia, but it is, there have been quite a few people who are doing work in here. So let's try Bogota. Okay, so we've got 82 map collections that folks have created. Let's just open one of them. So there's a group that is clearly using world maps to do a bunch of stuff, because all of those look like they were coming from the same group. Let's see what he's working on. Yeah, and so Google is now not working well for us. We've been struggling with the changes in the API. I think we're probably just going to, we'll see what we're going to do with that. So here's one guy who's got a couple errors. Now, let's imagine we were going to come in here, open a map, and start exploring through the search tool for stuff that we have on. Actually, I'm going to try Bogota. Okay, so let's zoom in a bit. See what we've got down for Bogota. Let's see what that is. So. Yeah, we can add those to our map. And let's zoom to a larger extent. So there's a fair amount of stuff in here already, and you can add your own content, update layers, rectify layers, and turn layers on and off. Here we have a historic data set. So this is a original plan for Bogota. Nope. So now we can save this layer once we log in. Okay, it's telling me I've already got one of those. So now that I've saved this, I can upload my own data. I can create my own data sets here online. I can make sort of fine-grained views of my layers. So let's take this one. Let's make this transparent. Okay, so now I've got a view. I might want to share this with someone else, another historian who's interested in looking at change in this part of the city. Of course, this can work in any city, anywhere in the world. And now I've got a URL with a hash that I can share, and that will allow me to let anybody else, they won't have to be logged into the system, and they can get a view. They can see exactly what I'm talking about, say, in a blog post or sent in any way across the web. So that's just a really quick picture of the kinds of things you can do. And let's just jump back here and all of the stuff I talked about is available on GitHub, and there's a lot more, quite a few more projects and sets of code in our CGA repository. Hope you'll check that stuff out. I'm sure this presentation will be available. If not, I will make it available. And with that, I think I'm a little early, but I'd like to open it up for questions and comments. So if you're interested in geospatial, if you're interested in Django and geospatial, if you're interested in platforms for to serve any purpose, we're especially knowledgeable about helping the academic community, please feel free to talk to me. Or just join the GeoNode world map community, and we'll see you online. Thank you.
Thanks, Ben, for that presentation.
Thank you.
So for Q&A, what we're going to do is we have two of our volunteers on each of the hallways, and each one of them is holding a microphone. So if you have a question, please raise your hand. They will approach you, and you can ask the question standing up and talking to the microphone. Remember to keep it close to your mouth, and go ahead, please.
Thanks very much for that. I want to stand up. How is this work being funded? Is this out of like Harvard funding 3 or 4 people, I think you said at the beginning, just building these tools for Harvard to use, or is it?
Great question. Yeah. So the whole thing's been funded by in little bits here and there. Some bits less little than others. but all coming from researchers, almost all, well, except for a couple of grants, like the HyperMap grant, NEH grant, and a couple of others. Probably 3/4 of it have come from scholars who wanted the system to do something that it didn't do at the time. So one example is a social scientist who's now at Northeastern. He was at Harvard, and he was very interested in integration with another platform out of Harvard called the Dataverse Network, social science repository. And he had lots and lots of stuff that he wanted to store in both places, all of it spatial, and wanted it to tie together. So, with that, and he got a little NSF grant, and we built sort of an API on each end. And so now in Dataverse, when you load a data set, there are 3 types: those which have lat longs in a table, those which have canonical spatial references like FIPS code or zip code or country code, and then just plain old spatial data. Any of those things now you can map from the Dataverse side, and all the geospatial stuff is taken care of on the world map side, and then it's sort of presented. It looks as though it's sort of all happening in Dataverse. The map services are reflected back. So that's an example. Lots of other little projects where we've enhanced it now. But that raises a really good question. That is long term. What do we do, right? So we got spoiled. We had a lot of Amazon grants for a while, and then those dried up. And they said, okay, you got to fly now. And luckily, we were able to sort of move quickly onto a new public cloud called Massachusetts Open Cloud, and we're now hosted on Massachusetts Open Cloud. And there's not really a shortage of this burgeoning sort of world of public clouds that we could host on. But that's all well and good for an academic, organization. I mean, this problem of sustainability for web-based platforms over time is a very real problem. And the kinds of systems that have been developed to answer that question, which I sort of criticized here. I don't think you can criticize too well unless you really have a good answer for how you maintain something, especially if you're making it free, right? So ours, we conceived all of this back in 2007, 2008, when that was just how everyone was thinking. But now, we have to figure this out too.
So I have a question about approaches that you've tried. I was recently talking to a friend in San Francisco who works at Descartes Labs, and they provide a geospatial data set, and one of the things they specialize in is geosearch. And he was describing that the way they handle it is they take tiles from users, a tile that the user wants to search for, and they run it through a neural net that embeds it into a smaller search space, basically. And then they do something like an FFT to figure out where the spikes that make that tile special are, and then they match it against a compressed data set of tiles that they have for the entire world. And they managed to get, sub 100 millisecond searches for tiles in huge multi-layer data sets. So I was wondering if you've experimented with any approach like that, or if you've used the Descartes Labs data set at all, because it's free and open to the public. It might be helpful.
That sounds really, really interesting. We have not gotten into that. We would get into it if somebody at Harvard or someone somewhere wanted us to get into it, somewhat independent of whether we want to get into it. So that whole thing is available. So it's basically metadata about a vast cache. Is that right?
Sort of.
Because it's not the cache itself. That would be just absolutely massive.
So they don't really cache anything. they actually have
Yeah.
all of the tiles, and they run it through a network that embeds it into a smaller space.
Right.
And that way they can sort of match the spikes that make each tile special.
Right.
So their first approach was actually using Elasticsearch, and then they ended up switching to this. But it's not just tile search. They also have metadata. So they have like locations of wind turbines. They have like oil refineries. They have a lot of the similar data sets that you have up there, and they can do sort of relational searches for queries between those items as well.
And when they need to pull up the map, what are they doing?
I'm not sure exactly the details
Yeah.
of how it works, but maybe we can talk
It's
afterwards.
totally on my
if you'd like
radar.
to.
Yeah, I'm going to check it out. Thank you.
Cool.
Yeah. Any other thoughts, questions, concerns?
Hi.
Hi.
When using world map, I wasn't able to understand correctly. Is for visualization only? We can create layers of different information there, but in terms of where the information come from, how we can feed a world map to show this information? It has a unique way, or we can connect different data sources. It has some kind of processing power, or we just need to feed pre-processed information into world map to just print it.
Right, right. So what do you want to do? I mean, your first question, I think, was where is the data coming from?
Yes. Well, yeah. That's the first question. And if we can use different data sources, or we just need to use a very specific format to feed the application.
Like if you want to upload data yourself to the system?
Yes.
Right. So shape files or GeoTIFF files. So for vector data, shape. For raster, GeoTIFF. And the new version supports actually a few more. The new version is going to support GeoJSON and KML. And in addition, breaks some of the other limitations of shapefiles, so unlimited string lengths, any character, well, UTF-8 and actually various encodings are currently supported. Those will continue to be. But I don't know if I answered your question. So yeah, so are you thinking about programmatically uploading data to World Map?
Yes.
Then we should talk, probably. But I'd love to work with you and figure out how to do that. Especially since, we're not getting a lot of limitations from public cloud folks who want to do the hosting. Our limitation is more on the manpower side and the code development side. That's a shout out to anybody here who's a coder who'd be interested in getting involved. I'd love to talk to you if there are ways that we can do things which line up with your interests, which also could help build or improve this system. And there are a lot of folks out in the GeoNode community are working on the next version of GeoNode, which you'll just become part of that community.
Great. Thank you.
Hello.
Hi.
Hi there, Ben. First, thanks for coming here and showing us all the incredible work. And I have two questions. One is, probably you said this at the beginning of the talk, I was not here, I'm really sorry, is how can we consume this data? Is there any APIs that we can use?
WMF, any layer that you see in the system is available via an API. I don't put there's a very simple formula for creating the URL for any layer. I don't put that on our website just because we've been worried about getting overloaded by folks who are, just hitting the server that way without caching it themselves. But anybody who's interested in doing that, so I'll just tell you how. So any layer in there can be viewed in any other system. I should have made that point better. Actually, I probably should have demoed doing that. So you could take any layer and view it in QGIS or view it in ArcGIS or pretty much, or other web systems as well, using WMS. We could also do WFS as well, which is the actual streaming the features.
Okay, and just the second question, it's like, is there any way that we can contribute as, let's say, infrastructure work, or help you guys with the organizations of the service, data, or improving something on that side?
Absolutely, yeah.
Yeah?
Yeah.
Okay, that's cool.
Yeah. So, yeah, just shoot me an email
Okay.
or talk to me. Yeah,
Okay.
I'll be here.
Well, thank you.
Okay.
Hi there. Is there any limitation to use this tool by a government institution?
No. Any limitation to using the platform? No.
And well, currently many government institutions they have using the a private software, right?
Right.
And is there any way to migrate that information to that?
Definitely. Yeah, it's probably not hard. I mean, not knowing the system, but we've done that. We've done that kind of work a lot, and yeah, I know that in my previous life and other jobs, that's a big part of, being managing GIS systems is just the data translation, data conversion. But yeah, no, that's not hard. Yeah, so talk to me. Do you have somebody in mind? Maybe? No.